with Siam. How is everybody doing? Good. Thank you very much for attending my talk on multiplayer games with WebXR. So today I'm going to tell you a story, and this story is a compilation of many different experiences. Some of them include my first experience with virtual reality, the challenges that I faced, why I felt that WebVR was the right choice to make, my love story with A-Frame, and finally various other experiences and thoughts as a result of which I created a series of demos. So this story will take you through a journey where you learn to leverage different possibilities and components to create your own WebXR game. So this story has an element of nostalgia as well, because we'll be using the Pokemon demos for this presentation. So let's get started. Yes, that's me despite the little resemblance. My name is Tanay Pant, and I currently work as an operations analyst at ResearchGate in Berlin. I'm also a part of two really amazing programs within Mozilla, the Tech Speakers program and the Representatives program. So if anybody of you would like to know more about them, feel free to grab me after this talk. I'm also an inter-software innovator in the field of IoT and have published books on Firefox OS, virtual assistant for Raspberry Pi, and web-based virtual reality. And of course, I love Pokemons, but we'll talk about that later. That's my Twitter handle, and I'll be publishing the link to the GitHub repo where I'll showcase all the demos that I'll be showing in this talk. So make sure to watch that space. Okay, so last night I was debating whether we should do this or not, but since it's the first talk in the conference, let's jazz up the energy in this room a bit. So if you'll bear with me for a few minutes, I would request all of you to stand up on your seats. It will take only a few minutes. Okay, so let's do something which I call the open web stretch, and here it goes. So first of all, we try to reach high up there for all the open source streams. Reach really high up there. Then we come down, get to the grassroots. Then we come back up and blow the winds of change. Then we lean forward and shake the money tree for fundraising. Give it a good shake. And then we lean left to avoid the NSA. Then we lean right to avoid the FSB. And then we go all around to avoid both the NSA and FSB. And we are done. Thank you so much. Please have your seats. So how many of you have had experience with virtual reality before? Okay. So my first experience with virtual reality was when my father one day got me something called Google Cardboard. And it was quite interesting, as he just took his mobile phone, opened an app in it, and put it in the device, and I was teleported to a different place. I was suddenly on a roller coaster, and it was spectacular. It was love at first sight. And as time passed by, I did learn that VR is not useful just for gaming and entertainment, but for a variety of use cases as well. So if you're an engineering student, it's quite interesting to truly visualize the 3D models that you create in softwares like AutoCAD in a 3D space. If you're an artist or a painter, it's quite interesting to be able to paint in a 3D space using something like Google Tilt Brush or a painter. And not so long ago, Samsung created a demo which allowed people which had acrophobia, which is the fear of heights, to be able to overcome their fears in a safe and simulated environment. And that resonated with me a lot because I myself have a fear of unguarded heights, and if you ask me to get rid of it by standing on the top of this building, I would be pissed off. So this shows how VR can be useful for the improvement and betterment of mankind as well. So time passed by and I was in college and I had all the free time in the world, and I decided I want to make a VR application. And by that time, there were already quite some VR applications, and there were a lot of devices, and each of them had a different SDK. And the size of each SDK was in gigabytes. Are you kidding me? I had a quota of 1 gigabyte per day in my university, and my university was not well known for its internet bandwidth. And if I did manage to create an app using those SDKs, I was doubtful that my batchmates in college were actually going to download or install the app. And these SDKs did have a steep learning curve. and you need to submit your applications to the App Store, and they act as a gatekeeper before you can publish your own apps. And there were just too many points of friction, and it was quite demotivating, especially for a freshman student like me. And we have PowerPoint quitting right now. Thank you, Apple. What do you guys prefer, Google Slides or PowerPoint?
Keynote.
Keynote. Okay, we did manage to reopen that. So, where were we? So, there were quite some points of friction, and one day I heard about WebXR. What is this? Can a browser even display graphics at a good enough rate to match performance of native apps? I was quite skeptical. But then it made quite a compelling case. It was open. Anybody could publish anything because it's the web, of course. And different VR scenes could be connected to each other by the means of hyperlinks or portals. And one could have instant VR experiences. No need to download a lot of data and install applications. It's as easy as sending a link to your friends over Facebook Messenger or Telegram, and the person just has to click on it. This indeed seemed like something which I would like to try. Moreover, I already knew JavaScript, HTML, and CSS. I was really psyched. I was going to make my first VR application, and then I learned it's not that easy. If I may ask, how many of you have used WebGL or 3GS before? 2 people. So these are very crucial components of making a web VR application, and if you've used those, you might agree with me that they have a pretty steep learning curve themselves. And you need to install VR effects, preload assets, initialize the scene, set up lighting, control, camera, renderers. I truly do not want to go through all this trouble just to create a simple prototype, and that's quite a lot of boilerplate which needs updating with new version of libraries. And if you haven't dealt with this before, how likely are you to create a hello world program for WebVR? Okay, so as expected, and at this point, I'm really close to abandoning my dream of creating a VR application. My exams got started in the university, but after a month browsing through Twitter, I came through something called A-Frame. So apparently Mozilla started this new team called MozVR, and they were working on developing this framework. I thought, okay, let's give this one last shot. So A-Frame is a declarative framework for building virtual reality experiences on the web. Fair enough. As I started to go through the examples and documentation, I must say I was quite impressed. It was designed in such a way that it made prototyping really easy for web developers to work with. And if you had no previous graphics experiences, it made experimenting really easy. It was the perfect vehicle to kick off the WebVR ecosystem. So this is a WebVR Hello World program written using A-Frame. As you can see, it's just HTML. You can start by dropping a script tag, no build steps required. One line of HTML, ascene handle all the different components that we talked about, like canvas, camera, render, lights, WebVR effect, polyfills. And for further development, we put our stuff inside the ascene tags. So let's take a quick look at what we have here. So we have different primitive geometries like box, cylinder, sphere, plane, and each have their own attributes for position and rotation in the form of X, Y, and Z axis. Now, A-Frame is an entity component framework. Have any of you used Unity 3D before? 3 people. So Unity is a gaming engine, and entity component system is quite popular in game development and is used by softwares like Unity. All the objects in the scene are basically entities that are inherently empty objects, and you can plug in components to attach appearance, behavior, or functionality to these entities. Hence, the entity component framework provides an easy way to build up different kinds of objects. So these are some of the components that ship with A-frame. By the way, if you're worrying to be that you have to create something like Hermitage Museum just with boxes and cylinders, you can put your mind to ease because A-frame comes with different components like object model or collada model with which you can import 3D files in the form of .dae or .obj objects. And since A-frame is fully extensible at its core, the community has filled the ecosystem with tons of components. And these components can do whatever they want. Basically, they have full access to Three.js and the web APIs. And this component ecosystem is the lifeblood of A-frame. You can simply drop these components as script tags and use them straight from HTML. So this is an example of advanced developers empowering other developers and working on collecting these components. These components are collected and made available in the A-frame registry. So it's like a store of components that the A registry team makes sure work well, and people can browse and search for components or install them. Okay, enough talk. Let's look at some code examples. But before we continue, I would request you to kindly close your eyes for 5 seconds, recall your earliest memories of Pokemon. It might be if you watched them as a kid, or you watched them with your kids, or if you're like me, you maybe got hit by a door playing Pokemon Go. So I created a demo. Is it visible in the back? Yeah. Better? Okay, so let's continue the dim lights while we're looking at the code so everybody can see. So as you can see, it's just an HTML file. We started off by adding the script tag, which includes the A-frame minified library. And then we have initialized this whole thing with a scene, and you might see that I've added the fog component, which basically obscures objects at a certain distance from the camera in a fog. And you can also specify what kind of color you want to add to that. Then I have used the asset management system of A-frame. And here I have, so using asset management system helps in preloading and caching, so that improves the performance of the scene. And I have included various Pokemon models, basically all of them which I can find for free, on the internet in the form of .dae file. Then I went ahead and added 2 images which I'll be using as textures in the screen, one for the floor and one for a wall. And then I went ahead and started placing these different components all around the scene. So for example, here I placed a Pokemon ball and mentioned its position, and also I scaled it to a bigger size. So often when you will be downloading different models from the internet, they might not quite fit your scene, so you will have to either scale them down or scale them up. And also I've added an animation attribute to it so that it rotates about its central axis for 360 degrees. And then I have the various models which I basically included in the scene and positioned them so that they stand around a square. Here I have again used the box primitive object that we saw in the code before, and I have added a texture to it so that it looks like a wall. And finally, I added a sky and a plane so that everything that we have added to the scene stands on top of it. So let's take a look at what that gets us. So everything works as expected. We have a Pokeball here which is rotating about its central axis. Then we have different kinds of Pokemons that we added. I can see Pikachu, Squirtle, and you might notice that there's a goggle-shaped icon on the bottom right of the screen. So if you will open this scene, any A-frame scene up on a mobile. If you click on it, it basically splits your field of vision into two so that you can place them in a headset or something like Google Cardboard and experience it in virtual reality. So if you're on a mobile, you can go through the scene. If you move your mobile, it changes your field of vision, and you can point at places if you want to move through. And if you're on a laptop, you can use the WASD keypad to move from one place to another, and your mouse or your cursor to change your field of vision. So as you can see, I added the texture, which is kind of on the plane. Then we have the wall texture here on the primitive boxes and the different models that we included in the .dae file. Now, if we take a quick look at the code, you might say, okay, this is interesting, but having to enter a position like 12.45354, okay, this is quite annoying because that is quite some precision, and it's annoying to have to experiment these things. So to make things easier, A-Frame introduced something called the A-Frame Inspector. So you can basically invoke it by pressing Control, Option, and I, and you can use that on any scene. So this gives you a Unity-like editor, and you are able to see all the entities that are present in your scene. You can try to modify the scene straight from here. You can select any entity, you can move it, you can scale it, you can rotate it straight from here. And when you're selecting any particular entity, it also shows you here the paths of that particular entity. So for example, you can change here and include another model in its place. So now we have an edited scene, and we can download it in the form of a HTML file, and your settings or the changes that you have made will be saved. I have a question. So we have two Pikachus here. One is quite small, other is quite big. Why is that? The difference in sizes of Pikachu. So as I mentioned earlier, we have scaled this model because we have scaled it 25 times across all three axes, because the model of the Pokeball was quite small, so it had to be scaled to match the aesthetics of the scene. All right, moving on. Since A-Frame is based on HTML, it is compatible with all existing libraries and frameworks. And playing in a virtual world is much more fun with friends. So here's a demo which shows A-Frame using a component called networked A-Frame. So as you can see, I opened this scene with two sessions, one with my laptop and one with my mobile. So when I open it up with my mobile and I tap on the screen, it shows the other player, and it's giving me feedback by waving its hands. And if I put it down, mobile like this, it looks down. If I put it up, it looks up, and tapping on the screen gives it feedback so that I know it's my other player. So this is like a simulation of a conference room, much like this, and as soon as different people open up this scene, it will pop up different players. And what it does basically is it syncs the position and rotation data across all the devices using Firebase. So this is available on the A-Frame registry, and the component is called networked A-Frame. It also has adapters for WebSockets, DeepStream Hub, and other real-time databases. So I was quite happy having made that application. I had a working VR application which had Pokemons in it, but then I thought to take a step back and think about the term virtual reality. So we are trying to simulate something in such a way that looks as real as possible. Okay, we can probably use higher quality models which are more photorealistic. But when I was thinking about this problem, I came across this game called Pokemon Go. Have any of you played that or heard of it? Okay, 3 people. So it's a game where you go from place to place. It has augmented reality on it, and you can basically point at, let's say, that conference table, and there might be a Pokemon sitting on top of it. Then you try to flick Pokeballs on it, and if the flick is successful, it captures the Pokeball. And there's different Pokemons in different locations, so it's kind of geotagged. So this game was quite interesting and much better than what I was doing with WebVR. It basically took the real world and added a new layer of information on top of it. So AR, that seemed like the real deal at that time. So I did some more research on it and came across this library called ARJS. So adding a layer of information to the real world somehow made things seem even better or real. And ARJS had seamless integration with A-Frame. So this is how it works. ARJS comes with a couple of preset markers. One of them is hero. So it's basically like a thick bordered square with some characters in it. And when you use your mobile or your laptop, and when this library recognizes this certain pattern, it shows some 3D information. So let's take a look at the code. So we have included the library for ARJS along with A-Frame. And then we have added the tag aMarker, and the preset, we are using a preset here which is called hero. And then we ask it to position a box as soon as this marker is detected. So this seemed quite interesting to me, and this concept looked somehow better than what I was doing in the previous demo. So I decided, why not add Pokemons to it? So I created this demo where, like the previous demos, I added the A-Frame library, the ARJS library, then we have similar asset management system for A-Frame, and then I used the aMarker for preset hero. And inside, I displayed some 3D information. So one of them is similar Pokeball rotating about its axis, not that big though. And we have 4 Pokemons arranged around it from all the sides, like they're looking at a campfire or something. And let's take a look at what that gives us. So it will ask me for permission to use the camera. And hey, you can see me. So we will be using this marker, hero marker that we saw before. So as soon as it detects this hero marker, can we switch on lights? Okay, much better. Okay, my mobile is on auto rotation. So we get a Pokeball which is rotating about its central axis, and we have 4 Pokemons which are looking at it. And basically what this library did was detected this particular marker, and it displayed the information that we put inside aMarker. So let's get back to the presentation. So using just the preset markers was somehow not that scalable or personalized, because I wanted to create a game with my own markers, and I needed quite a bit of them. So the great thing about this library is that the creator of this library also provided us with a tool where we can upload our own images, and it generates a marker like this and a pattern file. And if you go ahead and try some of the tutorials about it, there's one thing you should keep in mind, that if you're using custom markers, the version of the library in those tutorials is outdated. So make sure you are using the correct version, because otherwise you might face some issues with using custom markers. So I wanted, this kind of suited what I wanted, and I wanted to create my own marker. So I went ahead and created another demo with a custom marker in it. Okay. PowerPoint is not being too friendly today. So here we are. We have the 2 libraries that we were including before. And instead of using just aMarker here like we were using earlier, we are now using a preset which is called custom because we'll be using a custom image in that. Then we are using the type pattern because I uploaded an image and that's in the type of a pattern. And then I'm pointing it to where the pattern file lives. So it's a .bat file. And this is generated when you upload your image to the tool. And I ask it to display just a JPEG file when that particular pattern is detected. So let's take a look at what that gives us. I'm sorry, I'll have to ask you to turn on the lights again. We can probably leave them on. All right, so it asks me again for the permission on the camera. Let's grant it that. So now if I show it the hero marker, it does not detect anything because we'll be using a custom marker. So the custom marker here is my name. And when it detects this marker, it just displays an image, JPEG image, which has my photo in it, my name, and my Twitter information. So before we move forward, I had a question. How many of you know about GLTF files? So GLTF files are basically, it is being called in the popular media as the JPEG of 3D models, and it has like really good runtime considerations because it's present in, so it's the structure of the file is something like this. It has a binary and it has a .gltf file, which is kind of like a JSON file, and it has other materials for the 3D model. And if you're using these models, this significantly improves the performance of the scene, and it has less memory consumption. So A-Frame actually has really good integration with GLTF models, probably even better than DAE models. So if you take a look here, is it visible? Is it? Okay. So what I've done here is we have added the same two libraries, the A-Frame.js, the minified version of AR.js, and then we have a new library which I got from the A-Frame registry called A-Frame Extras. So GLTF models can be animated, and I have included a model which I downloaded from the internet called Buster Drone, and it's an animated model. So what I did here was I added the component animation mixer so that I can bring in the animation that this model has to my web scene. So let's take a look at how that looks like. So this is a GLTF model, and it comes along with the animation. And using the awesome the A-Frame Extras library, we are able to include the animation that came along with this model to our web scene as well. So when we are making applications or games like this, what is really important is performance considerations. And performance is a crucial part of any web application. A-Frame allows you to monitor the stats of your application by adding the stats attribute to the ascene tag. And it will show you different statistics related to your scene up there. As you can see, I have included a lot of models for demo purposes, so that decreases the performance of this app. So it helps you to monitor various metrics like frame per second, aim for a stable 90 frame per second for WebXR 1.0 API. Textures, number of programs, geometries, vertices, faces, load time, and the various entities that are present in the scene. So how many of you have heard of Google Tilt Brush before? Google Tilt Brush? No? So it's a program with which you can paint in 3D. So it comes with HTC Vive, and A-Frame is quite powerful. To demonstrate that, the Moz VR team constructed a 90+ frame per second room scale tilt brush experience in just a few weeks with just A-Frame. So in a nutshell, VR is fun, and A-Frame makes developing VR content fun. So this concludes my talk. We discussed various components with which we can make a multiplayer game with WebXR, such as models in A-frame, animating them, adding multiplayer capabilities, and leveraging various AR capabilities. You can also utilize the many libraries that a registry has to add physics to your scene, for example. This allows you to create a game in which you can have a camera and you can have different markers hidden all over a conference menu, and then you can find them, scan them, find a Pokemon standing, which is kind of running around, and you are using the physics for collision detection, throw a Pokeball at it, and then try to catch it. And then, of course, the scores of the various players would be synced across various devices with a real-time database like Firebase. And of course, all this can be done, and this is present on my GitHub repo as well. And I can't wait to see what all of you are going to make out of it. Spasibo.
Thank you. Есть у вас вопросы? Okay. If you have any questions, you can ask. Okay. The first one.
Let me the first one. I noticed that we typically run applications through Firefox, but you have Safari default. Is there any limitation on the rendering platform? I'm not sure, maybe I can use OpenGL or something like this.
So issue with Safari is like sometimes like it has performance issues, and primarily I use Firefox because of this certain feature. So have you tried about performance in Firefox before?
50 years ago.
So I use it particularly because of this feature, so it allows me to load different web pages and know more about the performance of the application. It helps me benchmark like what's the CPU usage or the memory usage for that. So that's one of the reasons why I primarily use Firefox.
Okay, and let me extend my question. I saw frame rate was about 20-30 frames per second while your demo. Am I right thinking that it's software rendering, or there's some hardware behind?
So it's basically using the WebGL platform, because 3JS in a way it abstracts creating applications for WebGL, and you can think of A-frame as even a more abstract layer. So it's just rendering using WebGL.
Okay, thank you.
Thank you.
Если у кого-то есть вопросы, кто стесняется задать на английском, можете задать на русском переводе. Okay.
Just a quick question. What was the name of the 3D painting? One slide before, I didn't see the name on the.
So in HTC Vive, it's called Google Tilt Brush.
Tailbrush.
And this demo, you can run it in browser and you don't need any installations. So this one is called A-Painter. You can find it on A-Frame's website at aframe.io.
You can try it now.
We need controllers for painting.
Okay, more questions? I personally have one or two, and I understand how it works on Android phones or any phones that have a browser, but what about Oculus Rift or another headsets? I don't know exactly what it's like.
Yeah, so Mozilla recently rolled out Firefox Reality, which is like an immersive browser for headsets. But even with any stock browser, like Samsung has its default browser, you can open these demos in any of them. So basically having like most of the major browsers support WebVR, like Firefox, Chrome, Samsung Internet, the default browser that comes with that, right?
That's nice, yeah. It was the second question, actually. What browser supports? Okay. So, more questions?
I think it will be the last question. And the question is, how could I place any object not on marker, but on custom things like a table, if I want to load my model on table, so not without marker?
Okay, so you can do something like you can use the camera API, and you can have overlay over that because with A-frame you can add a layer to the canvas, so you can have the real-time video rendering on a canvas, and then you can place A-frame models on top of it.
Thank you. More questions? you can also catch Tanay after the talk, and I think we will stay here at least until lunch.
Yeah.
So, okay, make it personal. So, I think we should, again, applause.
Thank you very much.